Nuclear energy is the nation's largest source of carbon-free 24/7 electricity. It will be an important part of the solution to national and global energy challenges. U.S. nuclear energy facilities operated at record high efficiencies in 2014, generating nearly 20% of America's electricity. To ensure that nuclear energy remains safe and efficient, scientists are constantly developing improvements to reactor designs, components, safety systems, and fuel. As the nation's leading nuclear energy research facility, Idaho National Laboratory is enhancing this global understanding. In fact, the peaceful use of nuclear power to generate electricity was proven here, and Idaho's contribution to nuclear energy innovation has been ongoing for more than 6 decades. The lab's work is part of the reason that today's commercial nuclear fuels are more efficient than those of the past, which has reduced costs for utilities and customers. For example, INL research has led to advanced fuel designs and enabled the industry to safely double the operating life of its fuel. But there are still unanswered scientific questions related to these high-efficiency fuels. To ensure that radioactive byproducts remain safely contained, scientists need to understand how years of use have changed the fuel and its protective cladding materials. To maintain safe storage over the long term at utility locations around the U.S., industry and the NRC need better data about how higher efficiency fuels withstand extended storage conditions. National investments have built specialized facilities at Idaho National Laboratory that are ideally suited to answer such questions. The nonprofit organization that runs INL has created an internationally recognized nuclear energy research laboratory. In the past 10 years, INL has developed a set of capabilities that in many cases are unmatched in the nation or the world. The lab's work generates knowledge that can improve nuclear fuel efficiency, nuclear fuel recycling, nuclear non-proliferation, safe storage of long-lived nuclear materials, fuel resilience, and enhanced tolerance to accident conditions. That's why industry and the Department of Energy want INL to perform the cutting-edge research required to answer today's scientific questions. How well do high-efficiency nuclear fuel rods hold up after they leave reactors and spend years inside dry storage casks? Is the metal more brittle than expected? Can engineers improve the protective cladding that contains the fuel pellets and radioactive byproducts? How do modern fuels change recycling considerations? Can transportation or long-term storage cask designs be improved? For answers to these questions and more, the nation turns largely to INL, where scientists and engineers analyze the physics and chemistry of nuclear fuels. The lab's specialized infrastructure provides a one-stop shop for exactly this type of scientific research. These studies can be conducted using 2 small shipments of used commercial reactor fuel. This container shows the volume of all the pellets from a single shipment. Multiple safety barriers will contain these materials, and there is no credible pathway for them to reach the aquifer. In fact, for more than 50 years, nuclear fuel has been safely transported, stored, and researched at DOE's Idaho site without harming the environment. Contaminants being monitored and removed to protect the aquifer that underlies the INL site were not created by used fuel stored at the site. They were created by disposal practices that are now prohibited or by operating practices that have been vastly improved. That's why the 1995 settlement agreement that is protecting Idaho's environment allows DOE to ship a specified amount of used nuclear fuel to Idaho. The state and DOE also agreed in 2011 to allow small quantities of commercial fuel to come to INL for research purposes like those proposed today. In fact, the 1995 agreement had required DOE to designate INL as the DOE Spent Fuel Lead Laboratory, which by definition requires INL to work with nuclear materials such as used fuel. INL employs many dozens of skilled scientists, engineers, and technicians who have dedicated their careers to improving the safety, efficiency, and security of nuclear energy. They have access to some of the best facilities in the world. They are equipped to improve our understanding of nuclear physics, the durability of materials, and how to improve energy efficiency. But Idaho is not the only place in the country this research can be done, and other national labs are eager to attract the work. There is a real possibility that the industry and DOE could utilize other labs if issues around these shipments are not resolved. Yet the nation has made considerable investments to build the unmatched research capabilities at INL. America should capitalize on those investments by performing this important research at the laboratory most qualified for the work.